let's work this problem here. Assume first that x is between 1 and plus infinity. The 1 is not included. We define f of x as the following. Let f of t be e to 1 over ln of t. We want to integrate f of t between x and x plus 1. Here, x belongs to 1 plus infinity. The 1 is not included. Okay, we want to find the limit of f of x as x goes to infinity. This is a general problem that requires some attention for the function f that we are studying. But in this case, we are given this function here, we can deal with it. We have all the tools that we need to solve these kind of questions. A good way to start is we can graph this one here and see its behavior, and we can find some bounds of this integral here and study the limit. Okay, that's what we're gonna do. So the first thing that we're gonna do is we can graph this function e to 1 over ln of t. How to do that? So first we're gonna forget about the exponential. We first gonna draw 1 over ln of t. And we can get that from the exponential. We know how to do the exponential, and we know the graph of the exponential. The natural log. Okay, so this is the natural log of some t. And since here we are just focusing on x being between 1 and plus infinity, let's call it x. Let's call it x, okay, because we don't want to confuse you. And we want to see how this one behaves between 1 and plus infinity. In our case here, we can see that this is the reciprocal of this one, of the natural log. So when we are close to 1, we're gonna get close to infinity, and we're gonna keep decreasing, and we keep decreasing until we reach this point, which is e. You can solve this equation here. Ln of x is equal to 1 over ln of x, and you will see that x is e in this case. Okay, and this is the graph. This is the graph of 1 over ln of t or ln of x, it doesn't matter for now. When we add, or when we compose, in fact, with the exponential, it's not gonna change the behavior, it's gonna be still decreasing. Okay, so it's gonna be still decreasing. It will be amplified, but still it's gonna be decreasing. So we're gonna have a similar looking function when we do the exponential. In fact, this is what we're gonna have. Okay, so this is let's say this is e to 1 over ln of t. Okay, now we see that this one and this is 1. We are in 1, we go to infinity. So this is 1. And we are interested only in this interval. Now we can use some techniques that we know. We can integrate. This is our f of t. We can integrate it between x and x plus 1. Okay, here we need to pay attention. F of x is the integral of f of t between x and x plus 1. So this is the area for we assume that we are fixing x for now. We're gonna let it change. Okay, so this is f of x. And we can see that this function is decreasing. This is small f of x plus 1. This is small f of x. And we clearly see that the integral, which is in green, is bigger than this integral here. I'm going to put it in black. Okay, it's tilted to the right in black. This area here is this rectangle here that has width x plus 1 minus x, and the height is f of x plus 1. And also it's less, f of x, the big f of x, is less than this integral in red, which is has width x plus 1 minus x and height or length width f of x. When I do the simplification, I get 1 times f of x plus 1. That means f of x plus 1 is less than f of x less than f of x. This is the formula that I need, and it's the one that's going to help me find the limit. Now I can extend x to infinity. Since I know f of x now, because f of t is e to 1 over ln of t. Okay, this means that f of x is between e to 1 over ln of x and bigger than e to 1 over ln of x plus 1. Okay, now we almost done. Since the exponential is continuous, okay, I can take the limit here of f of x and the limit here from the left of e to 1 over ln of x plus 1, and here the limit of e to 1 over ln of x. I can take the limit inside, okay, because the exponential is continuous. And I know the limit of 1 over ln of x plus 1 is the same as the limit of ln of x. Okay? The limit of ln of x is infinity, and 1 over infinity is 0. So these, both of them are 0, and therefore when I take the exponential here, I'm going to get 1. Okay? So this is 1 less than the limit of f of x between less than 1, sorry. And this means, okay, so this is some kind of squeeze theorem. This means that the limit of f of x as x goes to infinity is 1. Okay, so I had to use some, this one here, when I take the exponential, when I can't take the limit to the top, I get e to 0, which is 1. This is, and I take the limit here on the right side as well. Since this is 0, and e to the power 0 is 1, e to the power 0 is 1, and I'm taking the limit inside because the exponential is continuous. I see that the limit of my integral is just 1. And this proves that this limit that we are looking for is just 1. Okay? So this is how we deal with these kind of questions. We can do something else like differentiating, but it will require more work. And here we are using the simple ideas that we know. Look at this idea of the smaller area and the bigger area that traps the area of the original function. It helps a lot. Okay? Thank you very much.